So the tech word of the day is vector databases, and these are a very important part of AI engineering. And databases have always been used in creating web applications and any application that you see on the internet. But the vector here is the important part. So I'll explain why these are important. So before getting into details, vectors let you do semantic search. Now, what is semantic search? Let's say you go on YouTube and you write how to fix a flat tire. You will see in the results that the titles of the videos might resemble exactly as how to fix a flat tire, and you might also see some search results where it will say changing a punctured wheel. This second result that it has given you, like the keywords are totally different, changing a punctured wheel, but if you see the meaning of both these sentences, they're quite similar. This is called semantic similarity or semantic searching. When your search results contain similar meaning results, and vectors make this possible. So now let's come to what is a vector. So boats, like as humans we know what boats are because we see them visually, but computers don't really know what boats are or what cats are. For them, everything is a number, like everything is defined as a number, and it is not one number. It could be one number, but usually it is not one number. So if you see ferries, it is a collection of numbers, and if you see boats, again it is a collection of numbers. And this is a vector of size 5, but you can have vectors of size 1000 also, where one word will be represented by 1000 numbers. So the next important thing to understand when we talk about vector databases and vectors is cosine similarity. So basically, if you want to find out how close two vectors are in meaning, you can use this mathematical formula. It's called cosine similarity, and it is a bunch of mathematical operations that are done on those numbers of the vectors, and it finds an angle between them. Now the closer the angle, the similar they are in meaning, and the wider the angle, they are basically far apart in their meaning. So if you see coffee and tea are very similar in meaning, so their angle will be very less. And if you see ball and crocodile, the angle between them will be a lot, so that means they are not similar in meaning. And this is how the words are then stored in a vector database. The closer meaning words are actually in a cluster or nearby, and you can see like bananas, green apple, pears, they're all fruits, so they are like close to each other. And then on the left side you see ships and boats which are close to each other, and on the bottom you see football, which is like a standalone. This is a visual space representation of a vector database. And if you talk about the current databases in the market which are quite famous, so you'll see the mention of these vector databases a lot. Pinecone is something you'll hear a lot. Milvus is there, Qdrant is there, Weaviate is there, Chroma, and LanceDB. And when it comes to job openings, you'll usually find the requirements of vector databases in like a AI ML software engineer position. So here you will see under preferred qualifications, knowledge of vector databases such as Pinecone, Weaviate, ChromaDB, or FAISS, which is I think by Facebook. And this is another job description. This is a AI forward engineer, and here also you'll see rack patterns plus vector search, and you'll see like Pinecone and PG vector. So this was the tech word of the day, and this is just a short description of what vector databases are.